1 second to get started.
Good morning, and welcome back to our sessions. This morning's session, if you're checking, is on water levels. Right now, we're going to have a talk on regional and statewide impact of groundwater flooding. And before we get started, I just wanted to acknowledge our sponsor of the session, Ontario Lake Management Planning. Be sure to take some time and visit their page, if you will, and patronize their site here during the convention if you can. This morning, as I said, we have one presentation until 10:45 on the regional impact of groundwater flooding. We have Adam Freyhofer, who's a program manager in the DNR drinking and groundwater program. He works out of Madison, and he's co-presenting today with Aaron Pruitt, who is a research scientist also with the DNR drinking and groundwater program. So I'll just turn it over to one of you two to start.
Great, thanks, Carol. Thanks for coming to our talk. We're going to be discussing some groundwater flooding issues that we've seen across Wisconsin. As Carol mentioned, I'm Aaron Pruitt. I'm a water resources scientist in the water use section of the DNR. Be co-presenting today with Adam Freyhofer, also in the water use section. The water use section works on groundwater quantity issues across the state. So, high capacity wells, Great Lakes diversions. And one issue that we've had come up a lot in the past couple of years is groundwater flooding. And, what is it? What can be done about it? So we wanted to talk today, an introduction on what groundwater flooding is. Talk a little bit about, how wet it is, how much water we're seeing and where. And Adam's going to talk about, things we can do to evaluate and manage groundwater flooding and a couple of options for mitigation. So when you say what is flooding, people have an idea in their minds that they immediately jump to. They think of something like, the Mississippi River in 1965, where the water levels in the river just came up above their bank full condition and started spreading out on the lands. If you're not that old, you maybe remember other floods like the Kickapoo in 2018, where you're seeing these water levels come up from the river and start spreading out across the land. And that's what people think of when they go to flooding. And what that type of flooding is, in this general water cycle where you have precipitation coming down and it's either running off the surface or infiltrating into the groundwater system, and then it's eventually flowing out to a larger water body. In Wisconsin, it's usually a river or a lake. And what most people think about when they're thinking about flooding is this slow rise of rivers or lakes as they come up. But groundwater flooding is a slightly different beast. We have to think about it in a slightly different way. It has slightly different causes, and you have a different response to it. So groundwater flooding is when this water table, you have so much infiltration that the water table comes up and comes above the land surface. So this is just a hypothetical seepage lake, which we have several of across Wisconsin. And the level in the lake is actually a representation of the top of the groundwater system. That's just the expression of the water table at the surface. So when you have a lot of wet weather, this water level comes up and starts going up above the land surface and expanding outward, and you get flooding. And when you start having drought conditions, that water level can go back down below average to the point where you have dry lakes. And this is just, it can be from natural variability in the climates. It can be from other anthropogenic impacts. But this groundwater flooding we're talking about is just when this water table comes up above the land surface. And what it looks like, if you've ever been driving on the interstate north of Madison, you probably recognize this field. It's a strawberry farm just to the west side of the interstate as you're heading north out of Madison and the forest. And this was a picture of that field that many people will recognize. They have their trailer with their logo on it. And this is July 2018. And just over a year later, that, strawberry farm has become a pond. And I don't think they're going to get that trailer moving. I don't think any of those crops survived. That tree is probably waterlogged. And those, if they have basements in any of these buildings, they probably have sump pumps going nonstop. But you'll notice this is into forest. We're not talking about a major river coming up above its banks. We're not talking about, a Great Lake coming up above the shoreline. This is just water level from the groundwater system coming up to the surface. So what is groundwater flooding? It's the slow rise of the water table up above the surface, and it's caused by an extended period of wet weather. This isn't a case of a big storm or a couple of big precipitation events. It's taking months to years to slowly build up. And because it takes so long to get to this groundwater flooding level, it takes a long time for it to recede also. This is slightly different than what most people think of when they think of flooding, which is more of an event-based flooding type thing where you have, one big storm or a couple of big storms come through. There's too much rain to soak into the ground and too much for the streams to carry that water away quickly. And so the rivers fill up, go above their bank, spread out over the land. But those type of, event-based flooding, that starts in, hours, maybe days. And then it takes, about a little bit longer to recede. So it can take, days to weeks to recede. But I will note that these two things, this sort of event-based flooding where you have one big storm and groundwater flooding, which is the slow rise over time, they're not mutually exclusive. So if you have very wet conditions, if you've been having a lot of rain recently, then that makes it easier for this event-based flooding to occur. The ground is already saturated, so a big storm rolls through and that water can't go to groundwater, it can't infiltrate, so it goes to the river and you have these event-based flooding. So they're sort of intermingled a little bit, and they do exacerbate each other. So how wet is it? How much water are we seeing across the state? Another, just a nice visual indicator here is Plainfield Lake, which is a seepage lake in Waushara County. In August of 2016, you were looking out, this is still technically a lake. There is water out there, but there's a lot of grass, there's a lot of vegetation. You would get your feet wet if you tried to walk all the way across it, but it wouldn't go much past your ankles. And by April of 2017, you're seeing this, open water across the entire lake. And this is just because of the amount of precipitation we got over that winter, and it was melting and causing the groundwater levels to come up during that period. One way we like to think about this, one analogy we like to use is, think of the groundwater system as a bank. And, you have deposits of water coming in, you have your precipitation, you have water coming in, groundwater flowing in from elsewhere, you have surface water coming in, and you also have your withdrawals. You're losing water to evapotranspiration, you're losing water to runoff, in some places you have pumping, and you have some groundwater and surface water flowing out of the system. And you can track your balance in the aquifer, in the groundwater system, by measuring things like base flow. That's, the stream flow under normal conditions when you don't have, not right after a big rain event. You can track your lake levels, you can track your groundwater levels, and that sort of tracks the balance of the water in your groundwater bank, in your system. So we rely on a lot of our partners, and we've done some work ourselves to help track what the balance is in Wisconsin. So we partnered with the Wisconsin Geological and Natural History Survey to do some springs inventory. So that's where groundwater is discharging at the surface. And they've identified and tracked and measured a lot of those springs throughout the state. And we've started taking over some of that monitoring as well. And we've been working with the USGS. They have a lot of real-time gauges of depth to water in monitoring wells across the state. They've been tracking lake levels with their staff gauges, across the state in a lot of areas. And then a lot of work measuring stream flows across the state. And we've also partnered with UW-Stevens Point to do some monthly base flow monitoring, where they're going out and finding streams in the Central Sands, specifically near Stevens Point area, and monitoring or measuring the stream flow in those streams. And we have data from Stevens Point going back to 2005 is when that data collection started. And this helps us track the balance. You can go through, we have a website that we'll share at the end for groundwater quantity viewer from the DNR, where you can sort of access some of these gauges and levels. And a lot of this information is also available. The USGS information is available through the USGS's own website. So you can track and see where stream flows, where lake levels, where groundwater levels are right now compared to where they were in the past. And so if we do that, we can look at specific locations. This happens to be a monitoring well up in Burnett County, where we have data going back to the late 1930s. So this is a great record. Most wells and most monitoring points don't have this long a history. There weren't as many monitoring wells in the 30s as there are now. But you can see coming out of the 30s, this part of the state was still coming out of that sort of Dust Bowl Great Depression era where they had very low water levels. So this is depth to water is listed on the left. That's converted into an actual elevation on the right. And you can see the water levels, came up pretty quickly in the 40s and 50s, and then they were just sort of, bouncing around. You can maybe see a trend, but in the past few years, they've just continued going up. And we have a couple more examples. This is a monitoring well here in Dane County, between Madison and Middleton. It only has data going back to the early 80s, but you're still seeing a similar trend where water levels going up and down. Had hitting a really dry point around 2005 and 2006. It rebounded, it came up, and then in the past couple of years, it's continued coming up by 10 feet or more during that period. And here's another example in Waushara County, I believe near Wautoma. And it has, another nice long data set going back to the 50s, and you can see these drought conditions in the 50s, late 50s and early 60s, where the water levels were very low. Coming up into the 70s and 80s, it goes up and down a little bit, but then it starts coming up in the past couple years. And this one, it doesn't look like it's coming up quite as much, but you'll notice that the depth to water measurement that it's coming up to is 0 feet below the ground surface. So you're actually getting measurements here by 2018 where the water level was above the top of the well. You were starting to see the actual groundwater flooding, that expression of the water table at the surface had actually come up above the well right here in Washera County. Another thing we can look at is tracking the deposits into the system, how much water we're coming in. So this is the running sum of precipitation each year at Stevens Point since 1950. So each of those little gray lines is an individual year, and we're just adding up the precipitation as we go throughout the year. And that dark black line is the average throughout the year. So, you know, on average, there's about 32 inches of rain per year in Stevens Point. Other parts of the state, it varies a little bit, but you know, generally about 30 inches of rain is, you know, typically what we get. But every year since 2014 has been wetter than average, and in a lot of cases, it's been much wetter than average. So all the colored lines here are the years since 2014. So you can pick out 2015 in this sort of orange color where we were having, you know, a pretty dry winter, a pretty dry spring. Then we started getting into summer. We've made it above average. And then by the fall, it had come up and we ended up with one of the wetter years on record with over 40 inches of rain by 2015. 2019, we started the year wet. It continued to be wet through the spring. It got wetter during the summer, and then it got very wet during the fall. And we wound up with, I think, over 42 inches of rain that year. It was the, if not the second wettest year on record. In 2020, which we have bolded here, was no exception. We're still above the average. You know, we were tracking sort of average conditions in 2020 through the early parts of the year in winter into the spring. Then we had just a really wet summer that bumped our total up, and then it ended up just slightly wetter than average. Another way we like to look at this deposit coming into the system is called a cumulative precipitation anomaly. I won't get into all the math behind it, but the whole idea is that we take a long-term average precipitation amount, and then we, for every month, we figure out if it is above or below the average precipitation. And that difference is what we're summing up over the period. So if you had a dry January, it would be, the graph, the light blue line here would go down a little bit. If it was then a very, very wet February, it would go back up. And you can, once you do that for a long enough time, like we have here in Washera County, you get a probability of occurrence. How often do you see these, you know, several wet months, several dry months? And what we can see is, you know, we have these dry periods in the 1910s, these dry periods where it's pretty low in the 30s and the late 50s, early 60s. You know, we were worried about a lot of droughts in this area in the 2005s, 2010s. And that's, you know, coming down, but not our lowest lows, according to this, for precipitation. And in the past couple of years, again, we're just off the charts high. It's not that we have had a wet season. It is not that we have had a wet year. It is we have had, you know, a good 5 or 6 years of very wet conditions. And one thing we found is that this precipitation anomaly, this light blue line, it actually tracks very well with the water levels. So those are the blue dots that you see on this graph. And you can see how the groundwater usually mimics pretty closely the precipitation trends from this precipitation anomaly that this way we're looking at it. And we've done this across the state, and everywhere we look, we're seeing basically off the charts, just very long period of very wet weather. Up in Burnett County, we've seen the water levels just come way up. We've seen it in Forest, we're seeing it in Marathon. I just showed you Washira. We're seeing water levels that are very high in Walworth. We're seeing it in Dane. Everywhere we look, it is just, we have had a lot of rain. And when we translate that, tracking those deposits, tracking those balances, where are we seeing groundwater flooding across the state? Well, we've had a lot of rain across the state, and we're seeing flooding across the state. From the northeast up in Burnett, we've seen it in the Central Sands, in Adams and Waupun. We've seen it in Dane County. Here, we're seeing it in the south, in the southeast. We've seen it up in Marinette. Just we've had these issues across the state. So now I'm going to turn it over to Adam, and he's going to discuss, how can we evaluate and manage the groundwater flooding and some potential mitigation for these issues. Adam?
Great, thanks, Aaron. Yeah, so I'm going to walk through a question we get a lot at DNR is, well, Aaron talked about how we've used the science, how we use the data to help inform us. And then the next question is, well, what are these trends doing to my lake? Or my area. I'm seeing water levels go up. How do we deal with this? So I'm going to walk through an example of a desktop exercise that DNR has used in the past to better understand what's going on in certain regions of the state. We use a couple of different things. Aaron talked about the surface elevation, the land, when you're standing on the ground, what's the elevation of that land? And then groundwater hydrology, where's the water table, the top of the saturated aquifer, where's that relative to where you're standing? Is it getting close to your feet, or is it further away below your feet? Which way is the groundwater coming from? How big is the bathtub, if you will? How big is that groundwater basin, and how's that groundwater flowing? We look at soils. Are the soils, indicative of a wet area, peat, wetland soils? Has this area typically seen these issues or not? That's another indicator we look at. And of course, climate. Aaron talked about looking at groundwater levels, the groundwater hydrology, in addition to the precipitation. So we're looking at that, what's going on in that area relative to the groundwater levels and precipitation. So we look at some of these variables, and I'll walk you through an example of what that looks like. So this is a lake in Walworth County, citizens around the lake, and up gradient of the lake, if you will, we're having concerns with high water levels, septic systems getting inundated, the water getting closer, to their homes. And so there was a little bit of concern about, well, is this going to keep happening? And then the other question is, well, what do we do about it? Can we put a high capacity well in and pump the water out? Can we, what can we do? So I'm going to walk through the things we looked at to better understand what has happened here. And just certain difference here on this slide, this image was taken during a relatively wet period, 2018, 2019. This is much earlier on when it was drier, 2005, 2006. And you can see that difference, that the water table is coming up, and therefore you have more water being exposed during this wet period than you would have the dry period. So if you bought a house in a dry period, you would thought everything's okay. Well, years later, obviously the water table's encroaching on things and making it a problem. So we look at elevation. Land surface elevation is extremely important. And so what I can do, those green dots you see on the map are just points I put as reference elevations. The area shaded in blue is wetland areas, and those around the upstream, if you will, of the lake. And it's the difference in that elevation. The further uphill you get, the less likely you are going to be susceptible to groundwater flooding. The area in shaded is wetlands, and those are more likely, lower elevations, more likely to be inundated with groundwater flooding during times of high water. And so again, elevation really does matter. And we're talking feet. I have this personally in my neighborhood. A neighbor a few houses down is lower than me. Their sump is running nonstop. I'm a little bit higher and I don't have that issue. Feet, really, inches sometimes matter with respect to the water table. So we look at the elevation and see where it is and how that references with respect to the water table. The other part is we look at the groundwater, which way we have groundwater table maps developed by the Wisconsin Geologic and Natural History Survey. We take a look here. The area in black hatched area is the surface watershed. So if you just looked at that, you'd say it's a pretty small watershed, but the ground, that's where when it rains, what comes into that lake from surface water runoff. But we're not looking at that. That's really topographically defined. The high areas define that. The groundwater basin is much, much bigger. And so you've got groundwater coming in from a much bigger area. And that's really what you need to look at with respect to groundwater flooding. When we say it's, the issue is the tip of the iceberg, it is, because below you there's a lot of groundwater. So we look at the basin, how big is that contributing basin of groundwater, and what direction is it flowing or moving. Again, we're looking at groundwater hydrology and climate. This is a graph that Aaron just went over. And, obviously in this case at Walworth County, we're in a really high water cycle, part of the water cycle, where it's been a lot of precipitation in multiple years. Again, you have these constant deposits. You aren't given, you're not having a break in the system. It's just one after another after another. I wish that's where how my bank account worked. It unfortunately doesn't. We haven't had as many withdrawals, and so we keep adding and adding to the problem. So if I do a cross section here of upstream of the lake, an area that was also having the flooding issues, the profile below shows the land surface in black, and then the aquifer, the top of that blue line is really the water table. And where that blue intersects the black line is where you're going to have groundwater showing up on the surface. That's where the groundwater flooding is, if you will. Sometimes that's not necessarily considered flooding. It's just where the wetlands are, and that's what keeps the wetlands healthy, and it's fine. When it goes up a little bit higher, when the image below shows the difference between the normal conditions and when the water table rises, you have more areas exposed. And again, it's all about elevation. It's where you are in the landscape relative to the water table. And so as that water table rises, more of these low areas are more likely to be exposed. How this looks on a county-wide level. When we apply that same kind of idea. Now, we don't have this type of product for everywhere in the state. I wish we did. It's a nice reference. But what Aaron did here is he took a water table map that was developed in the 80s from the Wisconsin Geologic Natural History Survey and looked how high the water table had come up since that water table was made through today. And he mapped that out and found all the areas that were within 4 feet. The land surface, or the water table, was in 4 feet of the land surface. So these are areas that would be more susceptible to groundwater flooding than others. And, it kind of matches to where we're seeing problems in Waushara County and the instances here. But yeah, it gives you an idea of, again, elevation is really important. And these are areas that are closer to areas that are lower in the landscape and closer to a water table, especially when that water table is rising. So this is an example of how we could look at it. Aaron mentioned some of the products the department has. We have a water quantity data viewer that we've put out that summarizes the water quantity data that DNR collects, as well as our partners, USGS and others, UW Stevens Point State Survey, in terms of putting it in one spot. So you can look at stream flows, lake levels, monitoring wells, and get that information. So that's a handy tool to be able to access. And all you have to do is Google Wisconsin DNR water use data viewer, and that pops up. The other is groundwater levels and aquifer response. This is a website we put together to address groundwater flooding several years ago when it started to rear its head as a topic of interest. And we try to keep that updated as we get additional questions. It's not necessarily site specific, but we do have some. We do try to keep the graphs updated with respect to where the water levels are relative to today. And you can search Google Wisconsin DNR groundwater flooding. By Googling that term, you should be able to get to this page. So those are two tools we have related to groundwater flooding. The next question we obviously get is, okay, so we know this is a problem right now. We know the water table is rising, and it may keep rising depending on what the precipitation cycles turn out to be in the coming years. What can we do about it? Well, for homeowners, one of the things is moving some of the valuables out of crawl spaces and basements, because, if your basement is lower in elevation, if that water table comes up, that's the first thing it's going to hit, is moving things, relocating things out of the basement. I'm going to be honest, anything on the mitigation side I'm covering here is not a cheap fix. So it's hard to, when we talk about surface water flooding, they always talk about moving homes out of the floodplain. Well, much like that, and we're not talking about moving the entire house, but we are talking about potentially moving utilities if you have a threat of a flooded basement. The other is a sump system, is installing a sump into the basement to basically do localized dewatering around your home. And you still are pumping the water out. And if you don't pump it far enough away, you could be cycling the water. You've got to move the water somewhere else. And so that becomes another concern. But dewatering is a helpful tool to keep the water out of the basement, out of the lower elevations of the property. So when we talk about the big picture of getting out of this problem, it comes back to Aaron's analogy with the bank. We really need at this point smaller deposits. So when I talk to folks, when Aaron talks to folks, it's an unfilling answer, which is, well, we just got to hope we get less rain at this point. 10 years ago, we were in many parts of the state, we were talking about drought, lakes drying up, people having concerns with, all sorts of water quantity issues on the other side. Now, 10 years later, it's the opposite. It just shows that the swings have been pretty great in the last decade. So looking at that, we need smaller deposits, larger withdrawals to bring us down a little bit. Of course, if you had that for the entirety, you're back to the other side of the issue, which is things drying up. So trying to find that balance, and it's hard to find. And this isn't just a issue related to the inland. This is also, as Aaron said, it's a statewide issue, but we see it on our coast, if you will, for Wisconsin. On the East Coast, we see it with Lake Michigan. Homes falling into the lake with coastal erosion because the water levels have been so high on Lake Michigan. We see it in the Mississippi. Water levels are extremely high in the Mississippi. So this is an issue for the whole system. The Wisconsin River, all the big rivers are full. The whole system is full. We talk about things, the simple and not always correct way of explaining this as a bathtub is, if the bathtub's full, some people have asked me, well, can't we pump around our lake or around our neighborhood, put in a well and pump it out? And I said, well, you got to get rid of that water somehow. So if you're going to pump it out of the bathtub and you're putting the water right back into the bathtub, you're not going to solve the problem. The other piece of it too is that groundwater flow. If you're dewatering and you're pulling water out, you're going to have to be doing that constantly, and you have to be doing it enough because you've got groundwater constantly coming towards you. Again, it's a little bit of a tip of an iceberg. You can't see the whole iceberg, but it's there, and it's powerful in that sense. And so this is, like I said, a larger issue, not just in individual seepage lakes or neighborhoods that are experiencing this. This is the whole system we're looking at. So whose problem is it? Well, it's Mother Nature's what's of course starting it. We certainly can attribute some of that to climatic changes we're seeing, where extremes are going higher or lower one way or the other. And then we get, as DNR particularly, we get, well, who's responsible for fixing it? And that is that's a tricky one because again, this is a natural phenomenon and one that's different than surface water flooding, event-based flooding that Aaron covered in the beginning. We've talked to our floodplain people, and this is not something that's typically groundwater flooding covered by homeowners insurance. Maybe some companies offer hydrostatic pressure issues related to groundwater flooding, but a lot don't. And so it's a little bit of a different beast, but it's certainly just as impactful. And in some instances, there may be a way to alleviate the issue. We've talked about, the homeowner fixes, talked about maybe if it's smaller, we can pump the water out. If the basin is smaller, the groundwater inputs are smaller, we could pump the water out and move it somewhere else. And hopefully, you want to avoid making it somebody else's problem, but move the water out and essentially de-water the area. But again, you've got to address the underlying issue. And if you can't, you're just dealing with some of the symptoms at that point. And I would say, just as I know before, this is rare. This is not one of those stories where I can tell you that there's an easy fix to this. There isn't. That trying to find a solution, in most cases, it's not possible. In some cases, there might be site-specific cases where you can engineer a solution. But as we point out, there are trade-offs. You have to move the water somewhere else. You have to get rid of the water, and it can be very, very expensive. So like I said, we get calls, we hear the panic in people's voices where the water is slowly creeping up to their home on the lake, and their septic systems being inundated, the water level is getting closer to the doorstep. You can hear the panic in the voice, and this is a really tough conversation to have at landowners, which is there's not much we can do about this, because below you, it's not just a small little issue around your home. It's a huge issue in terms of the water table and the aquifer. And, it's a real tough thing to deal with. So, with that's our overview on the issue as we've seen it from the Wisconsin DNR's perspective. Like I said, we're getting calls across the state on this issue, and trying to address them the best we can. But I think it's a tough conversation right now in the state, and all we can do is hope that the precipitation trends settle down a little bit. So with that, I'll turn it over for any questions we have and go from there.
Okay, thanks, Adam. And there are several questions. Well, the first one, your picture of the strawberry fields near DeForest drew a lot of attention. The question is, are they former wetlands where groundwater would have been attenuated if they had not been converted?
That's a good question. I haven't looked specifically to see if they're on old mapped wetlands. The soils in that part of the county tend to be, pretty well drained, silty loams. But if I had to guess, if we're seeing the water table at the surface now, then at some point in the past 10,000 years, we would have seen the water table at the surface in about the same locations. So it would have been, developing some of the soils and developing into wetlands if the water table was close enough to the surface most of the time for it to really develop into a wetland. Now, whether that's actually how much that would have attenuated the groundwater flooding is a slightly different question. When the water table is at the surface, you're getting open water evaporation. Like you can see on the road here, that's going to evaporate a lot quicker, and you're going to get more of the withdrawal from that. With the wetlands, you don't always have that open water evaporation, but you're also pulling water from just below the soil surface through the plants and transpiring. So it's kind of, it probably would have been a wetland at some point, and that may have helped, but it wouldn't be just an easy fix in this case.
Sure. Okay, and then some folks in Manitowoc County, Cedar Lake in particular has been at record highs. It's a seepage lake. Is groundwater high in this part of the state? Is there a website that has water tables in the state? And I think you may have touched on some of that, but you may want to go back through that.
Yeah, Manitowoc is also pretty high. I don't think it's quite as high as some of the places we're looking at, but it's still definitely high water levels. Lots of precipitation over the past few years. Specifically looking for water tables in the state. A lot of the information that we do have where we actually have those water tables mapped is available from the Wisconsin Geological and Natural History Survey. They tried to go through and create a map of the water table on a county scale to show where generally the groundwater is, where it's flowing. They unfortunately don't have groundwater table maps for the entire state. And I'm not sure if they have one for Manitowoc. But if you're just looking for water levels in wells or lake levels or stream flows, you can find a lot of that is accessible through that groundwater quantity website, the water data viewer that Adam shared. And a lot of it is available through the USGS website where they're tracking water levels.
Okay. Okay, we're hearing a lot about high water levels and diversions to lower lake levels. Actually, moving from one lake to the next now. Considering the amount of groundwater recharging a lake, this could involve moving a lot of water. How do we make sure we aren't harming the downstream?
Yeah, that's part of the issue that Adam brought up there was, pumping to lower the lake level, whether you stick your pump in the lake or if you stick it in a well right next to the lake. You don't know if you can actually move enough water to lower the lake level. That is a very large amount of water. The next issue is, where do you put the water? You can dump it into the next lake, but that's going to make that lake go up. That's just transferring your problem to the next person downstream. And it may not even work. You may just be, you would still have a problem, and now your neighbor would still have a problem. And that's why we have to say that this is very site specific. In a few cases, there is a way to pump the water and discharge it nearby, and you can get some reduction, but in a lot of cases, you're just spreading the problem around.
Yeah, and to add to that, that's just from the hydrology side. Then you need to start thinking about water quality, invasive species. It becomes a whole lot of DNR programs, what it becomes, getting involved, because you need to think about, well, what's that movement of water from your lake going to mean to somebody else with respect to, phosphorus or invasives or things like that. So it does become like I said, a complex and expensive endeavor just to determine if it's feasible, let alone to do it.
Thanks. Question on water quality. Do elevated water tables make it more likely contaminants from the surface will make their way into drinking water?
Well, that's a great question. What the example I showed at Walworth County, the residents were slightly up on the hill, but their septics were a little bit lower and closer to the water table. And so if you have a septic system that's going to get inundated, is there a concern with that? Yeah. To what degree does that, what does that mean in terms of water quality concerns? I couldn't say with definitive answer what it means, but I do think that the rising water table intersecting with the potential contaminants does have the potential to cause some issues, certainly. And I think the septics are a great example of that.
Great. We just have some affirmation, I guess, that we should really emphasize the general futility of trying to pump water away. It's far larger than what people see on the surface.
Yep, that's a great point. In addition to whether pumping your lake levels or groundwater levels down, if that would even be effective, it would be cost effective. If you're just moving the problem somewhere else, it's like digging at the bottom edge of a very large pile of sand. For every time you take out a shovel's worth of sand, more just keeps piling down on top of what you just dug out. So, you know, you're not actually you're getting rid of some water, but you're also making more room for the stuff upgrading in view to just come back in.
Yes. A lot of frustration there. To what
Yeah.
extent are surface water flooding events made worse by ongoing groundwater flooding?
They definitely do exacerbate each other. So it was a few years ago now, Dane County had a big, 14-inch thunderstorm come through, just dumped a lot of water out in the western side of the county. That much precipitation, it doesn't really matter how wet or dry the preceding conditions were. When you're getting that much rain, it's going to cause some flooding issues. With groundwater flooding, when you have these already saturated conditions, then you start seeing, it doesn't take as big of a storm to cause, that level or as much runoff.
Sure. Okay, here's a pretty tough one. So for urban areas that maybe were developed in the 30s or during the Dust Bowl when things were dry, what do you see as the role of the homeowner versus the city to adapt, particularly if groundwater infrastructure like sewer laterals are starting to fail because of high water tables? Pretty loaded question, but.
Yeah, I mean, well, you're seeing that even. Well, a great example of that is, we'll go back to, where Aaron and I live in Dane County. Is a couple of years ago, the lakes, part as an impact from that 14-inch event that Aaron mentioned in Dane County, the lakes, the main lakes, Mendota, Monona, and through the chain of lakes in that part of Dane County started to come up. And this was all, it was surface water flooding, but it was also groundwater flooding. And the system, it wasn't draining. The whole system was full. And they were the infrastructure, the roads were flooded. It was causing transportation issues into the city. They've had to rethink how they're going to handle that. And they started to look at, in terms of flooding, inundation maps and starting to prepare for that. And it's the same thing here. It's like, well, if you're, with Washera County and their emergency management group, they're looking at where, I think they have Highway 21 in Washera County. It's prone to groundwater flooding. Well, they're going to have to rethink that. Are they going to have to raise that road up? And that's part of their master plan in terms of preparing for the future. It's like I said, this is the probability of occurrence of what we're seeing right now is really remote. We didn't think we were going to see this. So I think on the city side, on the urban side, that's where they need to work on things, is trying to, when things do have to get replaced, factoring in this into the equation. It's like, don't forget about this. We as humans, especially what I've seen with water levels, we tend to be really thinking about just the recent history and not the long term. And I've learned a lot looking at all this water level stuff, particularly since the 1930s, where we've got great records. This stuff will come back and we need to be prepared for it, particularly with the climate swings we're seeing more of now. And so from the homeowner's perspective, I think it's, being, for those that have homes right on a seepage lake, it's trying to figure out, well, what can I do to mitigate this? Can I put in a sump? Is that going to do anything? Can we get higher up? Well, that's a really tough question and a very expensive one, even if it's possible. So there can be limited things based on existing infrastructure we could do without having a huge price tag. But I think in terms of planning for new things and replacement of things, we should not forget what's happening right now. Because when it's dry, it's like, oh, I wish my house was closer to the lake because the water levels receding. But the opposite can come true in a matter of a decade.
Well, I think you handled that well. A little both. Is it against the policy to pump water from one watershed to another, or from one seepage lake to another? I know there's probably a variety of policy there.
I can start this. I think, when we have an issue where a lake association, let's say, wants to pump water out of their lake to deal with their issues, it's a multi program DNR response, and sometimes it's got to be even people outside DNR that have to evaluate it. In terms of water use, Aaron mentioned we deal with the Great Lakes Compact. We can't have water being moved from the Lake Michigan basin to the Mississippi. That's a no-no. And so as part of the compact, that'd be considered a diversion. And so that's a clear distinction. Beyond that, then it becomes more case by case in terms of looking at the feasibility of it and what issues exist. I don't think there's any law necessarily beyond the compact necessarily prohibiting it, but we'd have to look on a case by case basis.
Yeah, I think you're right. And, it looks at, like you mentioned, AIS, we can't be moving in AIS and we can't be transferring water quality problems around. So it's a lot to look at.
Yeah.
Specific question from Walworth County, Springfed Lake, Turtle Lake. We have 2 permanent staff gauges on our lake. A resident scientist has a significant amount of data, including a report he wrote summarizing data from 08 to 18. Would you be interested in our data?
Yeah, we're always willing to take the data. Part of where I see the water use section at the DNR, I mean, we've taken over more of the water quantity monitoring side, statewide effort over the last few years. And I think once we finish up a big study that we're working on right now, I think our attention is going to be focused on developing a set of reference lakes across the state that we monitor. And I think any data we have to take a look as we start selecting what reference lakes we do, and then also what additional lakes we monitor. And this is for long-term monitoring. What we've learned over the last few years, both with respect to groundwater flooding, high capacity wells, a lot of different issues we deal with, is that history really matters. Having long-term records really matters. So we take the data. We're always happy to utilize it and see what the goal is to see if we can get it, get data. If it's been, if we can QA/QC it, getting it into our data system so that people can take a look at it more easily.
And I'll add on to that real quickly. That's we have worked with county conservation departments and with citizen science groups who do want to go out and collect this data wherever they can, and we have been able to incorporate that data into our database that we've used for monitoring. So we would definitely be interested in more data.
And here they ask, are there grants available for helping homes get out of the water, flood mitigation? And what about preserving the water quality of the lake? So that's 2 questions there.
I am unaware of any grants, and not that they're not there. I'm just not aware of them. That may be a little bit out of my realm. Maybe more of a question for the county level staff in terms of mitigation and things like that from groundwater flooding. Like I said, I mean, we've been involved with a couple of counties, Burnett County, Washara County, working with their county conservationists on these issues, their emergency management folks on these issues. But I'm unaware of any available funding to deal with individual homeowner issues. Like I said, it doesn't mean that it doesn't exist. It's just that I'm not aware about it.
My recollection is with riverine flooding, I mean, usually after a big event, there is an opportunity for removing structures and maybe some flood proofing. I know in the case of groundwater flooding, it's a little bit different animal for FEMA and the flood mitigation folks. So like you say, probably not impossible, but not something we see a lot of. Groundwater recharge is typically viewed as a beneficial process in urban areas to offset the impacts of pumping and impervious surfaces. At what point do we discourage enhanced recharge due to groundwater flooding?
Great. Yeah, it's kind of can't have the best of both worlds, huh? I would say in urban areas that groundwater recharge is still extremely beneficial. Coming from my former job, which was modeling water quality for total maximum daily loads for DNR, I view the impact from urban areas, phosphorus runoff, things like that, to be great. So I look at that as still beneficial. It's nothing we should take away. It's what we see right now is so unusual. It doesn't mean we won't see it over, again, but historically speaking, we've not seen anything like this in terms of flooding issues. I wouldn't want to wipe away all the work that's been done on urban recharge, because we're gonna need that. You're gonna need that for water quality purposes. You'll need it for groundwater purposes. It's not something you want to discourage. I think that would be my take. That's my own opinion on that.
Is the state thinking of developing a flooding warning planning system like the state of Iowa? And again, I think we may be a little out of our expertise here, but.
Well, I know Iowa's got stuff related to surface water, but I'm not sure about the groundwater side of things. I wasn't aware of that. It's something we work, as part of groundwater management things. We do work with our friends in Michigan, Minnesota, and Iowa quite a bit. So I can certainly look into that and see what they're doing on that side. So thanks for the idea.
And now we're asking for another crystal ball. What's the forecast for the next few years?
I think we're all hoping it's a little drier. It's hard to say. I mean, I don't know, Aaron.
Yeah, forecasting is always tough. You can, forecast the weather a week or so in advance, and you can forecast climate sort of like 10 to 30 years in advance. It's that in between that is very hard to forecast very well, and we don't know. Given how wet things have been over the past few years, I would kind of expect things to go back to a more average condition, but there's no guarantee of that.
Yeah, and I think ultimately what we're looking at is that ultimately we would need heading into 2021 is that this year doesn't have to be a drought, but it just be, less wet than the past 5 years have been. You need something a little bit less so the system can start to drain, basically. So the Great Lakes can come down, the Mississippi can come down, the whole system can start to come down. And that's what we need to happen right now. Doesn't have to be a huge drought, just needs to be a small change.
Yeah, so precipitation in 2020 was still a little above average, but still so much less than we had been getting, that even though it was above average precipitation, we've started to see water levels, maybe come around the bends and start to come down a little bit. We need to continue that, closer to average or even below average precipitation to keep that going, keep those groundwater levels coming down.
We got just a couple more here. We try to wrap this up. Are the groundwater modeling tools, are there any that we can use to predict future conflicts and plan?
Yeah, there are some groundwater modeling tools available. Unfortunately, it's not great statewide coverage. The groundwater models that exist tend to be built for a specific purpose, asking a specific question, and they're not available everywhere that you can just use right out of the box. But there are a few that you could use to figure out, if we get this much precipitation, then we'll see groundwater flooding in these spots. Another way to go about that and sort of ask the same question is you can just sort of use these water table maps, the ones that the state survey has available for several counties, and that will, you can figure out the areas close to the water table where the water table is pretty shallow, and that's a good first step type of exercise to figure out generally where can you expect groundwater flooding. Well, generally low-lying areas where the water table is already near the surface, and that's sort of an immediate step that you can do in the matter of weeks versus something like a groundwater model, which would take months to years to get an answer to that question.
Well, thanks. We have one question. Melting ice caps, do they contribute to the groundwater levels? Might be more of a question about climate change.
I think, I mean, my take on that would be that the change in that ice cover is going to change more of the entire climatic cycle, and you know, the way the climate patterns are working, and that potentially could impact the precipitation trends, and that's locally where you see the groundwater flooding. So direct oceanic increases from the melting, maybe not directly, but I think the climatic changes from that, and what it means for precipitation in Wisconsin, that certainly could have a direct role. Unclear to what effect, but yeah, there's a potential for it for sure.
Great. Well, we're up to 10:45. We're about ready for a break here, so we've got a few questions, but we answered quite a few of them. Again, I want to thank Adam and Aaron today. That was a great presentation, great hour. We are going to take a short break and then ask everyone to join the plenary session at 11 through the event space. And then we have another hour of presentations in this stream starting at noon.
Great. Well, thank you, everyone.
Thank you.